So today in class, we're talking about precipitation reactions, and these are really special types of double replacement reactions, really most double replacement reactions, in which one of the products is a solid precipitate. So what this will look like is you have AB plus CD, and remember that A and C are positive, most likely, B and D are negative, and we get a little double switch here, so we get AD plus CB. Now, if we're mixing solutions, we're going to know that these are both aqueous, which means dissolved in water. So what should we put for the states of matter for my products? Well, you got to inspect that solubility table. So there's lots of different solubility tables, and I would just look at the one you're given, and you have to be able to analyze data. And it looks like this is one talking about soluble ions mostly, and here's some exceptions. And then it looks like these are some insoluble ions, and here's some exceptions. Remember, if it's ever soluble, that means it's AQ. I know this is maybe a little counterintuitive, but it's not the S. The S would be solid if it's insoluble, and that solid is always a precipitate. So let's go back to this. Now, if both of these products are aqueous still, it really means all of this was dissolved in water at the beginning, and it's all dissolved in water at the end. And really, that means no reaction has happened. You just mix two things together. So let's be careful with that. So let's look at some example problems now. So for this first problem, it says we're mixing iron 3 nitrate solution. So that would be Fe plus 3, NO3 minus 1, so FeNO3 3, plus sodium hydroxide. Now the molecular equation is just the one we're used to, so it's the whole thing. These would both be aqueous because it told us we're dealing with solutions. Now, what are our products going to be here? Let's switch these up. So the iron will go with the OH, so we get FeOH, except the Fe is a plus 3 and the OH is a minus 1, so I guess it would be OH3. And then my other product would be my NaNO3. And remember, we don't carry over the subscripts necessarily. This is a plus 1, minus 1. So this ionic compound is already balanced. Okay, once we predict our products and balance the charges, now we balance the coefficients. So it looks like I have 3 nitrates here, so I need a 3 right here. I have 1 sodium and 3 sodium, so I need a 3 right here. And now we're balanced. Now, what are we going to have here for our states of matter? This is where we got to look at the solubility table. So iron hydroxide. As I skim through this, I really don't see iron anywhere. So let's look at the other ion, the hydroxide. There it is. It says hydroxide ions are typically insoluble. If it's with potassium, sodium, barium, or lithium, they might be soluble. So I guess this does not defy the rule, so it would be insoluble. And when it's insoluble, we write an S there. This forms a solid. This is a precipitate. Now the other product here, sodium nitrate. It looks like sodiums are always soluble in water. So this would be aqueous or AQ. So the molecular equation is the one we're used to. Now next, the complete ionic is separating all these substances down into their respective ions. So I just start at the very beginning. It's not an iron ion, it's an iron 3 ion. So the charge, so we have to write Fe plus 3 and AQ. And this is going to get tedious, but we have to include all these states of matter. Now right here, I don't have NO3 3, I have 3 NO3 minus ions. I have 3 sodium ions. I would just be careful here that you're including only the charge of the sodium. It's never going to be Na3 plus. Now you have 3 OH minuses. I'm just going to kind of go over into this space over here, and then we'll do the other problem somewhere else. Now on the product side, FeOH3 solid. That's a solid. That is not split apart in the water. That's not dissociated, so we have to leave it as a solid. And then I have 3 sodiums on this side. Make sure to get the state of matter in. And I have 3 nitrates on this side. So that's the complete ionic equation. It lists all the ions. Now, I like to do this gently so I don't erase things, but I kind of cross them out. The net ionic equation now will just eliminate ions you see on both sides. So it looks like I got 3 sodiums here and 3 sodiums here, so I'm going to get rid of that. It looks like I have 3 nitrates here and 3 nitrates here, and I can get rid of that. If you guys were showing this work for me and you cross them out, I'm okay with that as long as you have the net down below and you didn't erase them. So iron, nope. Hydroxide, nope. So it looks like my net ionic equation is that 1 iron 3 ion is going to react with 3 hydroxide ions to produce 1 iron hydroxide. That's my net ionic. Okay, let's do a couple other just solubility questions. Will a reaction occur if we mix sodium chloride with potassium chloride solutions? Now, this question is saying, will a reaction occur? I want us to not even look at the solubility and quickly hone in on, this is the same anion there. If we were to switch, the products are going to be the exact same. So this would be a no, like no reaction would occur. Look at how cool chemistry is. We get to predict the future. What happens if you mix sodium chloride and potassium chloride solutions? Nothing. They just mix together. Okay, this next question, what is the precipitate when a solution of cadmium, it tells us the charge here, +2 sulfate, so that would be CdSO4, +2 -2, so that's it. Reacts with a solution of potassium sulfide, K2S, +1 -2. I'm not worried about balancing charges here because this isn't asking me for any complete net ionic. It's just saying what's the precipitate. So let's check this one out. So the cadmium is going to go with the sulfur, and the potassium is going to go with the sulfate. And again, I'm not going to even balance this because I'm not concerned with balancing the equation. I just want to find out which is the precipitate. So cadmium sulfide. Looks like sulfides are typically insoluble, and cadmium is not one of those exceptions. And it looks like sodiums or potassiums are soluble. So this is going to be your precipitate for this problem. Okay, I hope this helps, and I'm going to make another video for the practice twos.